For those of you that, let me see if I can get the next slide. For those of you that don't know me, just a little bit of background. I've been in tech for about 16 years. In that time, I've worked in academia, Fortune 500s, Bank of America, AIG, all that stuff. Then in about 2018, I got really tired of all the red tape it takes to onboard emerging technology into like an enterprise or corporate place. So I left. I made the jump to working in startups. I started at a consulting startup focused on Kubernetes and OpenShift. And then in 2017, I left there for Sysdig, became a Kubernetes contributor and org member. And then in 2019, Jim Angel, Eddie Valalaba, and myself resurrected the Austin Kubernetes meetup. And we grew from about 600 members to over 1,000. So it was a pretty, big year for us down there. That same year, I did the contributor summit in San Diego, and then COVID hit. And like most of us, I've just been trying to navigate the torrential floods of Zoom meetings and virtual events. So yeah, I am a services and delivery guy. So I'm in the trenches with the tech. And that's what kind of we're going to talk about today. I just want to highlight some of the open source projects that I found really interesting, and maybe ones that could potentially be helpful to you or interesting to you as well. So let's talk about Kubecon NA 2020. I think we're starting to get the hang of this, maybe. Unlike Kubecon EU, for me, this one seemed like we're starting to kind of get a grasp on what these events should look like if we're going to have to do more of them in the future. The flow, I thought, really seemed to work, and some surprising unsanctioned channels popped up, like the hallway track, and they were really big hits. We put together this Rambly.app, which also integrated with Twitch. So inside you could watch the CNCF Twitch channel and hang out with your friends and still not miss the live stream, which was really fun. This was also a KubeCon that really highlighted a lot of early startups. I think at last count, there was about 38 in total, which is great. We also had a ton of zero-day events this round, right? We had like the Service MeshCon, Open Telemetry, Community Day, I think, Commons, and all the normal ones that are usually there. And with that, there were like 60 talks and breakouts about various open source projects, not just specific to CNCF. I mean, there were some sessions on some other things, which I thought was really great, right? Can we interact with the attendees at all, like DMs or something, or chat? Can they ask questions?
Yes, I think there is a chat, and so yeah, if you have any questions, and we also have rooms, so we can all go into rooms, and we will all have audio and video at the same time, I believe.
Okay, cool. But I was just going to ask, out of the people here, who all attended KubeCon North America, and if you did you get a chance to attend the hallway track and the Zoom meeting that Dim's had running like 24/7 all week in the Rambly?
So I was actually able to go, but I did not go to the track. I was kind of doing booth duty, but it sounded fun. It sounded like a good experience. I really wish I would have actually went. But yeah, I'm jelly. I'm very jealous.
Yeah, it was really cool. And what we found was like on this day zero, like everyone was like talking over each other. So then someone found the Rambly.app, right? And the further you move away from people, the less you can hear them. So you can kind of break off and have these conversations. And the Twitch thing, the integration there was like super cool. Nice. I thought, I thought it really worked out very well, in my opinion. I know for a fact, like I've talked to the CNCF, the hallway track will be back for KubeCon EU 2021 as an official channel. And people are already trying to come up with weird sort of things to do, like sideline like the Rambly app, so we can all interact together. which was awesome. And I also heard a rumor that Intranado will not be returning for EU 2021, right? Because of all the buggy stuff. And so let me just ask you this, Brian, Mars, what were y'all's favorite sessions?
So in my personal opinion, I don't know why, but my heart keeps running towards GitOps. So my favorite one was, I forgot her name, but it was the Weaveworks GitOps about how it's being adopted and the whole change. And so, I mean, to be honest, that was my absolute favorite. But what about you, Mars?
I have several. I have many. Like Raspberry Pi was cool. The High Scholar's Guide to Kubernetes was kind of awesome as well. But I guess for me will be the Justin Garrison for when he introduced containers. And he made basically he made the whole movie out of it, and it was awesome.
That's great.
It is, yeah. I mean, he put a lot of effort into it. It was beautiful.
Yeah,
absolutely.
Okay, he just keeps raising the bar higher and higher. How could you do that? Like, yeah.
Yeah, for sure. The two that really stuck out to me were the Paris and Nikita talk on a different kind of Kubernetes artifact, and then being an ex-Sysdigger, watching Leo talk about how to bypass Falco was like really just a cool thing, you know. So, yeah. So, so it's just summarize it a little bit. In my opinion, this one went way smoother outside the Intrado hiccups, you know. It was really fun, and then all the little, just the little side. I mean, it's not even hallway, but hallway tracks were like really cool, you know. Which brings me to talk about some of these projects, right? Now I understand that this isn't necessarily a Kubernetes-based project, but it is based on the Kubernetes idea of declarative everything. And it was still really talked about quite a bit in the hallway track and inside conversations that were being held at KubeCon. Out of everyone here, who is in ops? And in the past, have you provisioned bare metal in the data center or at home? Yeah.
Yeah, definitely. I still do it. And I definitely support Tinkerbell. Yeah.
Yeah, for sure. So this project is a Equinix Metal project. So formerly Packet, right? And on a side note, right? Equinix has been like really hiring a ton of people out of the community and just building this really like all-star team. It's kind of nuts. But anyway, bare metal provisioning is still a thing, right? Companies tend to over-provision their cloud infrastructure, either due to poor planning or just a good old-fashioned lift and shift. And they're learning that with that comes a steep price tag, and the cloud costs keep going up. You know, so due to this, we at my company and some others are starting to see an exodus from cloud providers back to the data center or some type of hybrid architecture. And so what Equinix Metal essentially did is they needed a methodology that was easy for DevOps groups to spin up and spin down bare metal servers. I mean, their main use case was to, spin up a bunch of worker nodes for Kubernetes, right? And pretty much taking the shift left idea to bare metal provisioning. And what they came up with is a API-driven solution to do this. And to accomplish this, they broke it out into 4 main microservices. So you have Boots, which is the DHCP and iPixie server, which is all written in Go. You have Hagel, and I'm probably mispronouncing that, but it's the metadata store service used by Tinkerbell and OC. And then you have OC, which is the in-memory installation environment, and it's based on Alpine. And then Tink, which is the provisioning and workflow engine that comes with a CLI, so you can build the templates and workflows and whatnot. There are 3 pieces of infrastructure required to run Tinkerbell. So you do need a Postgres database. You need a local image repository, or you can configure it for Quay or Docker Hub. And then you need Nginx, just for load balancing and stuff like that. Ingress and egress, whatever. And it supports virtually all architectures from like Intel and AMD to ARM 7 and 8, and from UEFI to BIOS. And the workflow kind of works like this. So the prerequisites are you have your provisioner up and running, this area right here. You have a targeted worker list with MAC addresses, so you can group various servers based on role by their MAC addresses. And then you have a template defined for those groups, which is really just a YAML file with the tasks you want the worker to perform after it boots up. And so first, the worker will iPXE boot into that Alpine distro running in memory. Second, the worker will call back to the provisioner and check for its workflow based on the MAC address. And then third, the provisioner will push that workflow to the worker for it to execute. So like, if you think about it like that, it's super helpful, not just with spinning up a bunch of bare metal nodes in like for a Kubernetes cluster, but you can literally have it do anything. I mean, you want it to install Ansible, blah, blah, blah. It's just a declarative YAML file, which is great. So bye-bye golden image, right? So that's what I have for that. Has anybody had a chance to play with Tinkerbell, think about it? What are everyone's thoughts on Tinkerbell?
I definitely would love to try it because it looks really cool, and I think I like the architecture, and it feels easier than Metal Cube, at least in my
yeah, absolutely. And I think they even might have a I don't know if it's a vagrant deployment or something like that. It's just kind of all in one, so you can you know, you can mess with it on just like your work, your desktop and stuff. So really fun. All right, the next one I'm going to talk about is Longhorn. Now, you might see that a lot of these projects, or the ones I'm talking about, tend to be like on-premise based projects, but that's kind of my background, right? Like I was a data center jockey for years, so I find this stuff really cool. So the Longhorn project is a CNCF sandbox project. It was highlighted at Kubecon EU 2020 and Kubecon North America. I just decided to bring it up here, actually literally earlier today, because I do think it's a really cool project. How many or who here are trying to back up persistent storage for stateful sets? I know I've had to do it in the past, or at least attempt to.
I was about to say, yes. It is a challenge for sure. Yes.
yeah. So you know, and even past that, you know, when you're talking about high availability storage in Kubernetes, you know, really a lot of companies think about, oh, but my storage array actually has that feature, and I don't have to worry about it. But that presents a whole, like, another big barrage of problems, especially if you're going to load that data back into Kubernetes. I know one of my past customers, I had to come up with a way to create backups for one of their databases they ran in their Kubernetes cluster. It ended up being a real hacky mess. It worked, but it was a custom image in a container, and that container needed privileges. Those privileges had to be vetted by the security team, blah, 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 blah. Again, it worked, but it was a major pain. And at that time, there really, I mean, this is just a year ago or something, right? At that time, there really wasn't a decent solution for backing up PVs. Everybody just assumed, oh, if I have a block device backup, it's fine, it'll work. But again, getting that back into the cluster if you restore something it's an even harder task, right? So Longhorn is trying to solve this, and from what I can tell so far, they are doing a pretty good job at it. It has the number to do, it has the ability to do a number of things. So you can replicate block storage across multiple nodes or data centers. You can take backups of persistent volumes and store them to S3 or NFS. You can create disaster recovery volumes that can be restored to a DR cluster. And then you can schedule recurring snapshots of a volume or recurring backups and push those to S3 or NFS. And that's just like a couple things. So you can see like the implications here for like backup and restore. A lot of the hard work they're really taking care of, and they do it in a really cool way. So essentially, you have these two components here. You have what it doesn't. So this pod one is supposed to be their manager, and then you have the engine. So the manager pod is deployed on each node from a daemon set, and it essentially creates and manages the volumes in the Kubernetes cluster, right? The Longhorn manager talks to the Kube API to create a Longhorn volume CRD. And when the Longhorn manager is asked to create a new volume, it creates a Longhorn engine instance, which you see right here. And every time a volume is created, something just like a side note, every time a volume is created, another engine instance is created. Now, those can add up if you're like having a bunch. I think the max resources each engine requires to run is like 0.25 CPU. I think that's the max though. So it creates this Longhorn engine instance on the node that the volume is attached to, and it creates a replica on each node where a replica will be placed. So the replica is actually like the volume itself, right? So when that volume is written to it, it synchronously replicates the volume across the nodes on the replicas. Again, it is super light, and we just kind of went over the resources. And I think the minimum node requirements are like 4 gig and 4 core or something. The backing storage really does need to be SSDs. You shouldn't use, or some kind of high performance disk. Don't use spindles. What's really cool is you can actually set your IOPS requirements and things like that on your PVs. So that really helps with trying to make sure that what you require for whatever application is actually there and you're getting the throughput and whatnot. So just one thing to note, Longhorn is a crash consistent block storage option. I know that's not like ideal, but you can trigger manually trigger a sync that will write any cached data to the disk. And every time you create a snapshot, it does that. So even if you have like a reoccurring snapshot or something, it will do that sync before it writes the data. I have actually tested backing up a Postgres PV to AWS S3 and restoring that back up to another cluster because this is like a problem. I get this, like these kind of questions asked all the time about backing up in Kubernetes. So it does work, and it works well for what I can tell. For backup solution, this is really the only one that I've found that is super useful. And like setting up Rancher, it's pretty easy to get going, and there is a UI. So if you want to use that sort of thing. Any thoughts or questions on Longhorn? Potential use cases?
I just want to say, this is a shout out to Rancher. I've been following Rancher for a long time, Darren Shepard and everything that they've been building. In fact, I think that's actually what that really brought me to containers is Rancher. And this is kind of before Kubernetes became super mainstream. So I just want to say, shout out to that, man. They're always building some, K3S, Longhorn. I absolutely enjoy what's the other, what's the one that's the 100? They're aiming for 100 million clusters. But they just build such cool things. Yeah, I just want to shout out to them.
Yeah, absolutely. They had like a really big 2019 and 2020 really. It's just with the acquisition stuff, those guys are like really killing it, and they're making what I really like. They make Kubernetes very usable and like user friendly to people, so people aren't so kind of skittish or standoffish about adopting this new technology that we call Kubernetes, right?
Right. And the one project that was talking about, I just forgot what it's called, was Fleet, right? Fleet is one of the ones that I need to go spend more time with. I don't know if you've seen that lately, but yeah. Longhorn is fantastic, and not to steal that thunder,
Right. So the last one I'm going to highlight. So just transparency. I work for StormForge. That being said, I never talk about projects just because I work for a company, and I don't work for a company if I don't like the projects, right? So if that makes any sense, I think that was a bit of a tongue twister, but this isn't like a shameless plug. This is really cool stuff. So we open source this at Kubecon, and when it comes to performance or load testing, there is an inherent problem with getting an accurate payload to test with that represents your production payload, right? And so to solve the problem, we've created this. Mars or Brian, are y'all doing any kind of load testing in your CI/CD pipeline or any QA Before it goes to prod, do you have to get some kind of load testing or sign off or something like that? Yeah. Yeah. So the problem is like a lot of the tools are like just guesstimating, or you might be able to record some kind of traffic or one specific protocol or something like that. But there's just no way to easily, well, actually it is pretty easy now, but there wasn't an easy way to get a payload to test with in your load testing tool or performance testing tools. So what we did, or what the engineers here did, and just side note, like most performance load testing tools out there today, they do have the ability to import a payload, like a HAR file or something like that, right? So what if you could run a sidecar in production, record your production traffic on any protocol, export it in just about any format, and send it to just about any location, and then use that payload to test against? I mean, that's pretty cool. And as someone who's used K6 and things like that, it's just it's not. This solves a big gap that has existed in the being able to do that. So I mean, as an ops guy and an infrastructure engineer, like it removes risk for me, so that any application I deploy into production, I know it's been tested against a payload that accurately represents what we have in production. So that's the gap that they identified. And across all the performance and load testing tools, it integrates with any one of them, as long as you can drop in a whatever file. Like by default, I think it does like a gzipped file. We can put it to HAR, CSV. There's just a ton of different formats that we can export this in. And just the simple fact that it integrates with any load and performance testing tool where you can drop in a payload is just money in the bank to me, right? If you can't tell by the name, github.com/rename-this, we are actively seeking the community to like help contribute and rename it. It's being led by Noah Abrams, so Mr. CNCF ambassador / developer advocate, really great guy. So feel free to reach out to myself or Noah if you're interested in this. I had planned to try and fit in like some demos for each one of these, and it just wasn't going to happen in the short amount of time. So, my apologies for that, but I'd be happy to talk to anyone about any one of these projects that kind of I've gone over. And really, that's about it. If you are interested in getting started contributing to Kubernetes, please feel free to reach out to me directly on the Kubernetes Slack. I'm Cody C, all lowercase. We are always looking for help in contributor experience and in docs and there's a bunch of places you can help out, even if you aren't a developer. I'm not a developer and I'm doing all sorts of stuff. So, feel free to reach out, and thanks for having me.
Yay. Thanks a lot, Cody. Appreciate it. And it was really nice. I've never heard about the Longhorn, so learned something new today. And VHS also looks really promising. So something new to try for Christmas break. So thank you.
This is great. Thank you.
Yeah. Yes. I think we will have, there is a question from FNU, Golapar Krishnan. How does Longhorn compare to Rook? And if you can talk maybe for a minute about that. You are muted. Sorry.
There we go. Yeah, so I mean, they're not really competing technologies, right? Rook is based off on Ceph, and that's a specific protocol. So to compare them isn't really the thing here. Now, if you're wanting the difference really would be. Rook is like essentially a storage class, a storage solution which you can deploy in the cloud and on premise if you wanted to. Really, Longhorn is meant to be just an on-premise solution for storage in Kubernetes. You can use it is a Longhorn volume. So in that right, it would be something that is kind of like a Ceph solution or something, but it's meant to be really fast and really. The thing that I've had issues with at Sysdig is we did lots of little writes, like millions of little writes all the time, collecting all those metrics, and Ceph just wasn't a solution that could keep up. And from what I see, this one can, because you're in control of the underlying hardware that's backing it, and they highly suggest not to use spindles, only SSD and above. So that's a good way to look at it. Mars, if you're talking, I think you're on mute.
Sorry. Thank you. Thanks a lot, Cody. I think it mutes automatically after a few seconds. Yeah, very smart tool. Anyway, I think we will have a joint session, a joint room after the end of the presentations, so around 6 o'clock. So if anyone has any more questions or just wants to hang out, we can ask more questions there. And with that, I will hand over to Josh. Thank you.
Hey guys, Josh Bottom here from Southlake, Texas. Glad to be here supporting the community. Hopefully you can see a couple slides I want to put up and then do a quick demo on Kubeflow. Can you guys see the first intro slide?
Yes. Yes.
So hi, I'm Josh Bottom. I'm based out of Southlake, Texas. I'm a Kubeflow Community product manager. I've been a product manager in Kubeflow since Kubeflow 0.5. And Kubeflow, we've had the same mission statement for the last 3 years. So Kubeflow now is 3 years old. David Aronchak from Microsoft likes to say this is the same statement we've had, and it's very hard to do, so we keep it. But we want to make it easy for everyone to develop, deploy, and manage a portable, composable, and distributed machine learning on Kubernetes. So that's a lot of words, but if you think about it in real life, you know, if you're developing machine learning models, often you're either doing it on your laptop or maybe on-prem and public cloud. And you need to support a lot of different types of frameworks. Maybe you're doing TensorFlow or PyTorch or Keras or scikit-learn, maybe even XGBoost to provide image classification or regression or lots of different types of solutions that people are looking for. And Kubeflow helps you to build, train, tune, and deploy a machine learning model. And it does this with Kubernetes, so it provides you that capability to leverage distributed compute with a variety of either CPU or GPU, and then also use auto scaling and node placement. So all that together gives you that delivery of operational and infrastructure efficiencies on Kubernetes. So as an open source project, this is a very complex stack that solves a very advanced problem. In Kubeflow, we just released Kubeflow release 1.2. This is our 10th release over the last 3 years. So we have a release about every quarter. We went application complete in November 20th, almost the last day of KubeCon. In a process standpoint, from a community, we've done some work to have each of the separate components of Kubeflow be able to define their roadmaps, whether it's the training operator or the hyperparameter tuner catib or some of the other tools, the pipelines. And we've also defined a versioning policy that defines whether an application or a component is stable, beta, or alpha. And then we've also had these application requirements that are a template for what it means to be stable. We track the deliveries in Kanban boards as well as issues. And when we're done, we have a change log and a release announcement. And you can see down here all of the stable components that Kubeflow now has delivered into 1.2. I know this is a bunch of words down here. You'll see in the demo how this comes to life in a few minutes. Machine learning is an advanced and complicated environment. And if you look at this pictorial here, you'll see that there's a workflow to deliver a machine learning model into production. And probably the difference between just regular code is that with machine learning, you also have to bring your data along. So you have your code and your data, and you may have your data scientists working on your ML code, and they're working out of an IDE like a notebook. And then they'll train their model. So they'll train the parameters inside the model to be able to predict the right answer. And then they'll tune that model with a hyperparameter tuner for all the parameters outside of the model itself. They may double check that with an AutoML tool that will make sure that if I'm using TensorFlow, maybe PyTorch is better. They can do some model analysis and look at the data sets pictorially or visually, as well as their code. And then they'll often develop pipelines. So one of the most important things about developing machine learning is the fact that you're not just doing it once. You continue to rebuild this pipeline as new code or new data comes in. And so while you're doing all this with your code, you're also bringing in data at the same time and running it through you're labeling that data. So now you can use it in test sets, in training sets. And then you also have a feature store so you can more easily start from a place that you've already done some training on and leverage and not have to continue to retrain on data sets that you already know the answer to. But anyway, as you're bringing these along, these two workflows, you bring them into the pipelines. You have an artifact store that's capturing all the artifacts, all the data, all the code, all the metadata and dependencies necessarily along the way. And then once you have all that done, you need to then put it into production. And usually the people involved in this is an ML engineer, and in the pipeline portion, and in the deployment is a DevOps engineer. So you can see there's different phases, there's handoffs from different teams, and there's both code and data. Now, what Kubeflow works to do is provide you a composable set of components. You don't have to use them all, but what it's really designed to do is make this workflow easier and make it work end to end and really go through those components that we've talked about and have all that run on Kubernetes, right? So you get that auto scaling, node placement, a very efficient infrastructure, as well as operational efficiencies that Kubernetes delivers. But one of the things that you'll find is that we have worked with folks in the Kubernetes in the Kubeflow environment for about the last 4 years, and we start to see these gaps come up, right? So there's a portability gap. When people need to deploy Kubeflow on their laptop and on-prem and in AWS or in a public cloud, it doesn't always deploy exactly the same. So you need some form of process, typically a GitOps process, to make that work better. There's an automation gap. So the data scientists in some of these workflows have to build Docker containers or know kubectl commands. And lots of times they just want to work in the notebook. And so there's work to make this automation easier. And then there's a reproducibility gap. So as you're going across that workflow, you want to be able to snapshot your complete environment, right? So the complete environment being the code, the data, as well as the metadata and the dependencies. And you want to do that in a programmable way. And then the last piece is a security gap. The open source version leaves people open to say, how do I access external databases perhaps from my notebook? And sometimes people may not use best practices like leaving credentials inside of a notebook. So there's best practices here that people need to pay attention to and leverage the Kubernetes native aspects. one of the things that our company does, we're one of the leaders, contributors to Kubeflow, is to surround Kubeflow with a couple of tools to make the life easier. One of them is an open source tool called Kale. And what Kale does is basically help from your notebook to build this pipeline without having to go and have the data scientist manually build Docker containers to do training or hyperparameter tuning, or even now into model deployment. So what that means is the data scientists can do more of these steps on their own. Now, in addition, there's credentials and secret management that have been incorporated into this stack that allows for auditing and compliance, as well as just better secret management. All that is running on top of the Kubernetes and the Kubernetes CSI, and then leveraged in with a scalable standards-based storage class. Using CSI, you can have a storage class, a snapshot store that is taking snapshots along the way that allows you to share your data or your complete data science environment across clouds, as well as provide the lineage to see where everything came from as you walk across these steps, providing that versioning that you need. So now I'll just go to a quick demo. This is the demo that we provided with Google at Kubecon. I'm going to do the 45 or 50-minute demo in about 7 minutes, so you're only going to get part of it. But we're going to show building a model, and then we're going to build a pipeline that trains that model. We'll tune the model. We'll do the hyperparameter tuning. We'll deploy and then monitor the model. And all of this you can run with a very easy way on AWS and GCP and their marketplaces. I'll show that, as well as the tutorial and the KubeCon workshop information. All those links work that can drive you through. MiniKF is mini Kubeflow. It's available both on GCP and on AWS, and it's very easy to set up. I'm just kind of showing you the click through that you go through. You go on to AWS Marketplace and you can find MiniKF, and you'll have, like, for example, all your tutorials are right here. And then you can just click through to provision this 40 node cluster and get it up and running. You just basically take the terms and conditions, almost all the defaults that you would have, you would keep, like the delivery method, the storage version, the region. You may pick something closer, right? Because you want to minimize your latency. You go one more click, and now you're into the last part of provisioning this. We'll go through 5 different things. You just use the defaults, choose to launch from website, EC2 instance, the VPC, and the S subnet. If you want to change those, you can, but you don't have to. The only thing you really have to provision is this right here, which is you have to create a security group and then put in your key pair. You hit launch, and in a few minutes, you'll get a screen basically that looks like this, which is a login screen to get into your Kubeflow. Now, this is integrated, or you can integrate it with your single sign-on via Istio and Dext. So that is at the Kubernetes layer, and then you have an OIDC capability to run into your AD or your Active Directory or your LDAP. But you can put in your username and your password, and what that does is allow you to get to the central dashboard, and it also maps you into a Kubernetes namespace that allows you to have isolation either for a team of users or a single user inside that namespace. So that gives you some good security from an environment, an enterprise standpoint. This is the Kubernetes or the Kubeflow central dashboard. You can see you've got your quick shortcuts, your recent notebooks, documentation, and pipelines. We're going to go in and start to investigate some of these components here. The notebooks, you can see there's volume manager. So we were talking about persistent volumes earlier. This shows you all the persistent volumes that you have running, and you can move files in and out of those persistent volumes very easily. all the models you're running, your snapshot store, all your pipelines that you've created, your hyperparameter tuners, and all your artifacts. In the interest of time, I'm going to get into the demonstration. I'm going to go right into a Jupyter notebook. This Jupyter notebook is a machine learning model. You probably may not be able to read this, but this is a Kale competition to build a vaccine for COVID-19. And basically what the model intends to do is to find the places, to find the molecule or the bases, I guess these branches are called bases, that won't break, right? That are safe from degradation. So if you're going to build a vaccine, you want to build it off of this base rather than one that's prone to cut, because the cutting ones then will degrade and not be viable as a vaccine. So what they've done is they've already sequenced all these, and they've gone through and they've looked at the places that are prone to cut. So they have a training set that they've created with 3,000 RNA molecules that we're going to use in training this model that we're going to build. Now, best practices here when you're building a model is first you have to install your packages. You can see that this is installing quite a bit of packages. Your Scikit, your Keras, your TensorFlow. This is a TensorFlow TFX library, TensorBoard, a few other things. Then another best practice is to go through your imports. So you bring in your NumPy, your pandas, and then another piece is to put your hyperparameters all in one place. These are parameters that affect your model but aren't in the model itself. And we'll talk about that a little bit more. Next is we'll go through 4 more steps, which is just loading your data into the model and then pre-processing this model. This is basically taking the representations of the sequences that are in letters and in characters and turning those into numbers. You do that via a tokenizer that has a dictionary. Once you've done that, then you train the model. So you run it through some code that says, okay, now I'm finding the places that are safe from degradation. And then you train the model on a data set that you know the answers to, and you continually improve the coefficient of the linear algebra equations in order to make sure that as you run through that equation, you're getting a model that predicts which one is actually going to show what that base is going to do. Is it going to cut? Is it going to break apart? Or is it going to be safe for degradation? And then after that, we'll evaluate the model with data that the model has never seen and make sure that it actually can predict well. And then we'll submit this to the Kale competition. Now, I went through that. It's pretty long, but what we really want to be able to get to is not just to do this once, but to do it multiple times. So we want to build a pipeline that goes through these steps that I just talked about. And that's what Kale does. Kale is an open source tool that's an extension to notebooks. And what it allows you to do is to tag cells within the notebook that will become pipeline steps. Each of these steps are Docker containers. So you basically come in and you say, this is a pipeline step. I want to call it load data. You give it a name, an arbitrary name, what it depends upon. This is the first step. So it doesn't, and whether it needs a GPU or not. You can see that this is very easy for a data scientist to do, rather than if otherwise he would have to take all this code right here, put it into a Docker container, put that into a repo, and then use that in a pipeline. The second step in his pipeline would be data preprocessing. And you can see here, this is again a pipeline step, very easily to identify it. You give it an arbitrary name, data preprocess, and you pick which step you want it to be dependent upon. in this case, load data. Now, in order to build my pipeline, I just hit this compile and run. It will then validate my notebook. It will snapshot it so I can reproduce this. I have a version of it, and then upload the pipeline. And in a few minutes, I will get a pipeline that looks like this direct acyclic graph. And as I said before, there's this shows how all the data is flowing and also the sequential processing of that model that we just built, right? And this is now in a pipeline that is reproducible. So if I do come up with new data or new code, it's very easy to run it through this process again. Now, each of these steps are snapshotted, and I can go in and investigate and alter any of these steps, and then rerun this process again in case I've made a bug. Now, the other piece about this is once I have my model working pretty well, there are parameters outside of the model that need to be tuned. These are called hyperparameters. So the hyperparameters are now you have the ability to tune them right from the notebook itself. This is like the learning rate, the batch size, the embedded, the dropouts, the sequence, the epochs. And then what this does is automatically figures out the right set of parameters to make your model run both efficiently and most accurately. So you can pick a search algorithm about how to pick those parameters. You keep one parameter constant, you move it up and down, and then you see if it gets better. If it does, you move in that direction, and then you work on the next parameter. And you're going to try to do this to minimize validation loss. So if I went and I go and run this cat tip job, again, it's going to snapshot my environment, compile it, and then run it. And I will start to see a graph that looks like this. This is a new UI that has come out, it's coming out in Kubeflow that allows you to tune your model very quickly. And what that means is typically I would run a bunch of different of those pipelines by adjusting all these parameters, this dropout, this dim, this batch size, the learning rate, in order to find the best validation loss, right? And I'm going to run, like in this case, I set this up only to run six pipelines, but you could run 20 of these, and each of them could take an hour to run. Now, this tool automatically runs all those for you and highlights the best one. So what we've done so far is we've made a machine learning model. We've made, then from that model, we've made a pipeline. Then from that pipeline, we've been able to run through a hyperparameter tuner, and we've tuned the hyperparameters. Now we want to put this into production. So to put it into production, we can click on this and it will show the actual pipeline that we had that actually delivered that model. And then we can dive into any of these steps, but really we want to go into model validation and look at the environment that was snapshotted basically programmatically. And then if we click on this button here, it will bring us to this snapshot store that has now captured the complete environment, data science environment at that step. All we have to do is click on that URL, and that enables us to take that environment and build a new notebook, which we can now serve our model from. We can call this serving model. And all we have to do is paste this in here, and it automatically fills all the parameters in to make our notebook. So it brings the proper custom image. It brings all the CPU and RAM settings that we need. It brings the workspace and the data volumes and all the dependencies that I need, all the configuration, everything I need. I hit launch, and it brings up that model basically in a new notebook. Now, I want to serve that model, which means I want to actually send data to it and have predictions come out. In order to do that, we've simplified that process to this step that I'm showing. Typically, you would have to build Docker containers and write a custom resource definition in order to run this. Instead, what you have is these 5 commands that are at the end of this notebook. The first one is this Kale command that brings in the serving utilities that allows us to be able to serve a model directly from the notebook using Kubeflow serving. Then this command right here packages the model appropriately, snapshots it, and then starts that serving process, which basically starts 2 containers, one with a transformer and one with a predictor. The transformer will take the data that comes in and transforms it and then sends it to the predictor, and the prediction will start to make predictions. So all these commands here, this is an interactive Jupyter notebook, so you can see that it's running through all the commands to actually put out the inference server. We've done that. Now, in order to send data, I prepare the data with this data statement here. I also have this new KF server command, which allows me to monitor my model, which we'll see in a second. And now by running this command right here, which is associated with my data set, I can actually see this model start to go and send data to it and bring predictions back. And over on my my monitoring, I can see my logs starting to log the data as it's being processed through the transformer. This is the log of the predictor. And then also, you'll see this start to spike up. This is a set of metrics that are now available directly to the data scientist from the notebook, where he can see now his CPU utilization, both for his predictor and his transformer, start to spike up, and see how the memory and all the different components of this are coming together. There's much more to this tutorial. In the interest of time and keeping this in 30 minutes, I'm going to just go back to say, look, you can go through this tutorial. It takes about 45 minutes to run through, but at the end of it, you'll learn a bit about how to run through, and all these are clickable links. They're easily to run in both AWS and GCP, and the tutorial is step-by-step. I think I showed it before. Kubeflow 1.3 is next. This is a release that will come in March of 2021. We're at the feature definition. All the working groups are now engaged. The notebooks, the hyperparameter tuner that you guys saw called CatTib, the pipelines, we showed that. KF serving, you saw serving a model. Training operators, those are for distributed training. When you run your training jobs across multiple nodes, you saw some training in this. And your manifests that use GitOps and customize for deploy. All those groups are working. My company, Ericto, is actually the release manager for Kubeflow 1.3. We're doing, AWS has been kind enough to provide the test infrastructure for this. So you've seen kind of a movement away from GCP. If you want to learn about deploying multi-node Kubeflow clusters, this manifest charter and working group notes is a place to start, and you can join into those meetings. Getting involved in Kubeflow, right? There's a Slack channel, there's a website, there's a Discuss mailing list, and we have weekly meetings. Definitely invite people to come. We get so many interesting projects that we work on that you'll just have a lot of fun. And if you're looking to upskill over the next holiday, this is a place where I think you can have a lot of fun, meet a lot of people, and potentially get some good personal feedback. So that's what I had. Hopefully it was helpful.
It was. Thank you very much, Josh. That was very entertaining, as usual.
Yeah, that
Thank
was
you.
great. That was fantastic. Thank you. That was awesome.
Yeah, it's a lot, right? I mean, there's a lot going on there. But look, if you could think of any of the hottest places to be right now, in my opinion, it's machine learning on top of Kubernetes.
Yes, that sounds like as buzzwordy and as awesome. I just don't get it.
And our community, I mean, although, you know, we have Microsoft and IBM and Google and AWS and everybody as top contributors, you also have some really cool contributors like Bloomberg and Ant and Cruise and all these people that are like, you saw that Kale model. You have all these people doing this stuff that you just get into interesting conversation. So I definitely engage and encourage people to have fun with machine learning in 2021.
Right. This is awesome. I was curious, what are your thoughts? I had seen a repository where they had basically this cool GitOps model with Kubeflow. I think it was called KubeStack. What is your opinion on, because I always wonder like how fast I can spin up my infrastructure. And this MLOps is always kind of interesting, but I just kind of wanted to see what your opinion was.
So we are, as a community, are revamping the manifests that are needed to deploy Kubeflow right now. And part of, if you go through the manifest working group, which was held this week, it got a little out of control because people were creating manifests in a lot of different places. So what we've gone back to is, let's get back to a single source of truth. Let's have a very structured way to build how you get to a place where you have each component's manifest defined. And then instead of using kfctl, which was a special command line from Kubeflow to do deployment, we're just using customize. And so we're going to use manifest with customize to deploy. And you can put deployment tools on top of that as well. But it at least gives you a very clean set to start from. And I think that as we work through and clean all that up in 1.3, I think you'll find that the process to deploy becomes much, much better and much more replicable, as well as repeatable with an audit trail.
Perfect. No, that makes complete sense. No, I think that is really cool, especially the idea of just kind of have that declarative kind of infrastructure and with the customize, you know, so that's awesome.
Yeah, it's a lot. It's a lot. But I appreciate the time to present to the community. And like I said, please come and join in. You'll have fun.
Yes. Thank you, Josh. Thank you. And